Okay, so communication in mathematics, and really what the textbook is just saying here, and forgive me, sorry, this isn't a particularly mathsy video, but it is important, really important actually. It is just saying the textbook is that when you show your work now, particularly at AS and A level, which is going to be trickier, your work should be clear to understand. It shouldn't just be a jumble of ideas where you're reading it or someone else is reading it thinking, what are they trying to say here? It should read like a story. So it should be clearly written, but also it should be a logical argument to what you're doing. So you might go wrong with your working, that is fine, but it should be clear where you've gone wrong. We shouldn't be looking at work thinking, well, how have they got to that? Okay, so what the book says here is that mathematicians are particularly valued for their ability to communicate their ideas precisely and support their assertions with formal arguments called proofs. So a few key things here, right? You're massively valued for the way that you present your work. You will get a lot of marks for that in your papers. That's really, really important. We've then got these things called proofs that help show arguments. And again, with these things called proofs, which we will see in a later video, it's just really important how we lay out our work. Okay, and it should be easy to follow with good logical reasoning. It just means like it's kind of step by step. We can follow what is going on. Okay, so section 1, which is looking at mathematical structures and arguments. So what the book is saying here is that mathematical ideas may be represented in many different ways, such as tables, diagrams, or words, and the two ones that the book goes through in more detail are these things called equations, which hopefully you've heard of before, and identities. But just quickly, just to recap on what these things are, what are these things? Again, there are many different mathematical ideas that we can use, but we're just going through two here, because that's what the textbook went through. So an equation. What is an equation? An equation is where you try to find a missing variable. And typically there's one solution, but there could be more than one solution for sure, like there is in this question here. So this equation here, x squared minus 1 is equal to 8. We're trying to find the missing variable, which in this case is going to have two solutions. Because we go and solve this, first of all, by adding on that 1 to both sides, we would get x squared being equal to 9. And then to get rid of that square, that's root both sides. And if you square root something, okay, you're going to get two solutions, plus or minus. So in this case, we're going to get plus or minus 3. So we've got two solutions, okay, x being equal to 3 or x being equal to minus 3. So in this case, this equation has got two solutions. And the reason is, right, if x is equal to 3, or 3 squared is 9, take 1 is 8. Makes sense? If x is negative 3, well, if you square minus 3 squared gives you plus 9, take away 1 is equal to 8. So this equation here has got two solutions, which is absolutely valid. The equation below is only going to have one solution. Okay, we could go and expand the brackets or manipulate this how you wanted to, but the solution here is going to be 5, because 5 take away 3 is 2, and 2 times 2 is equal to 4. So in this equation, right, the only solution is x being equal to 5. Okay, so the book is just saying here, just be careful. Okay, an equation, there could be more than one solution, or there could be one solution. So it's just being familiar with that. We've then got something called identities, which you would have seen at GCSE, but it's just recapping it. What is an identity? An identity is where your left-hand side, so the bit to the left of this identity sign, is exactly the same as on the right-hand side. So in this case, if we went and expanded this bracket, which I do, you will see this means the same thing as this over here, which means that for any value of a and b, whatever I substitute into this, my left-hand side, my right-hand side are going to be the same, which is not the case with an equation. So with this here, if I go and expand this bracket, a plus b squared, okay, because I'm squaring it, I'm really doing a plus b, I'm timesing it by itself, a plus b, and that is exactly the same thing as a squared plus 2ab plus b squared. If we go through this, okay, using our FOIL method, so expand the bracket, so a times a gives us a squared, which is nice. A times b is ab, and then b times a is ab again. So it's two lots of ab, so plus 2ab. Then we've got b times by b, which is plus b squared, which we can see that is exactly the same thing as what I've got on my right hand side, okay, which is a squared plus 2ab plus b squared. So an identity, the left-hand side is identical to the right-hand side. And that's the key thing here. So whatever the value of a or b is, both sides are going to be equal, which is not the case with an equation. if I chose my x value here to be equal to 5, 5 squared is 25, take away 1 is not equal to 8. It wouldn't work out. But with an identity, if a was 1 and if b was 2, for example, because both sides are literally the same thing, you're going to get the same thing on each side. Okay, so that is that. So then we've got an example here, and that will be the end of this video, which is this. It is 2x squared plus 12x minus 3, and then it's recognizing that this here is your identity sign. So this is exactly the same thing as some number a times bracket x plus p squared plus q. Find the values of a, p, and q. So what it's asking you to do here is to kind of expand this out and manipulate it so it looks like what's on the left-hand side. Then we can go and find the missing constant values a, p, and q. Okay, let's begin. And let's write this out because the video is mathematical communication. Let's do this properly. Let's write things out really clearly. So we've got, and the way that I refer to things is this part over here, I call my left-hand side of the, in this case, identity. So my left-hand side. And the bit on the right, I call my right-hand side. It just makes things easier to refer to. So the left-hand side, let's just keep it the same, which is 2x squared plus 12x minus 3. And that is the same thing as, and let's go and expand this bracket here first of all. So x plus p squared. And we've got the a there also, so we've got a. And then we've got to use a big bracket, and that's going to expand a plus p squared, which is the same thing as x plus p. X plus p. There we go. Okay. I've got to have that big bracket here on the outside because I've got to go and times through all of this here by a at the end. So I've got to have these brackets here. And I've also got that plus q on the end, which I cannot neglect. I cannot forget about. Okay. So my left-hand side is just going to be, keep it the same throughout this. So 2x squared plus 12x minus 3 is the same thing as, and then we're going to go and expand this bracket here using our FOIL again. So we're going to do x times x, x times p, p times x, and p times p. Okay, but again, we've still got that a, which is going to be the, got our big bracket. Well, x times x is going to give us x squared. We've then got x times by p, which is 1 of xp. We've then got p times x, which again is xp. So in total, we've got 2 lots of xp. And then finally, we've got ap times by p, which is p squared, so plus p squared, and we've got that plus q just on the end. Okay, let's now go and times through by this a. So we're going to take this a, and we're going to go and times a by the x squared, a by the 2xp, and then a times by the p squared. So it's like expanding your bracket again, but with 3 terms. So left-hand side, keeping it the same again, so 2x squared plus 12x minus 3 is the same thing as a times by x squared, we write as a x squared, and if we can, let's try and do it in alphabetical order. It's just mathematical, it's just the way that we do things. We've then got a times by 2xp, which is going to be positive 2a, and really should have written, sorry, px, keeping it in mathematical, in alphabetical order. So it should be px, they mean the same thing, px and xp are the same thing, but just keeping it in alphabetical order. And I've got a times by p squared, so plus a p squared on the end. And then I've also got that q on the end, which I cannot forget, so plus q, which I've got on the end. So what I can do now is, I can now go and compare the coefficients, because I've now got a square term, which I want over here. So let's go and do that in one colour. So I've got a something square term, I've got a something square term. I've then got this 12x term, okay, over here. So I want to compare this with my 2apx part, because they both have an x on the end. So I'm comparing coefficients. Coefficient just means the numbers before the x part. So there's 12 and there's 2ap. And then finally, I've got this minus 3, which I can go and compare with all of this ap squared plus q. Okay, ap squared plus q, it is just some number. Okay, where a, p, and q are some numbers that we're trying to find. Where I can begin here is, well, I've got ax squared. A must be equal to 2, because comparing the number before the x squared part, a is going to be 2. So I can go and say that my a value is going to be equal to 2. So that is my first value. Okay, a is 2. I can then look at this part here, where I've got 2apx. I now know the value of a to be equal to 2. So I can now go and compare this with 12x. So I can go and say that comparing the 12 with the 2AP, that I've got 12 is equal to 2AP, and I know that A is equal to 2. So I can go and say that 12 is equal to 2. My value of A is 2, so P. So 12 is equal to 4P, therefore P is going to be equal to 3, because 4 times 3 is 12. So there we go, P is equal to 3, that's my value of P. And then last but not least, I can now go and find my value of Q, because I've got the value of A, which is 2, I've got the value of P, which is 3, so I can find Q. So I can compare this part here with this part over here, this minus 3 part. So minus 3 is going to be equal to AP squared plus Q. And then we just go and substitute in our values of A and P. So A is equal to 2, so we've got 2. P is 3, but we're squaring it, so 3 squared plus Q. So minus 3 is equal to 3 squared is 9 times by 2 is 18 plus Q. Take away 18 from both sides, therefore Q is going to be equal to minus 21. So there we go. That is my value of Q. Okay, which hopefully you can see that clearly. But this question was just talking about really, right, the fact that this up here is an identity means that once I get this part here into the same format, and what I mean by that is I've got the x squared part, the x part, and then the number parts, okay, I can compare the coefficients, the numbers before each of those parts to find out my values of A, P, and Q. Thank you.